Hi, you're all welcome to our meetup. Today we have Darryl, who is going to talk to us about Lambda Durable Functions and, of course, compare that with Step Functions. Lambda Durable Functions, remember, was released last year and especially during reInvent. So I'll just let Darryl take over. And if you have any question, you can always drop it in the chat. Darryl, you can introduce yourself and
Yeah.
you take over.
Okay. So thank you, Cyril. Thank you, everybody, for showing up. I'm Darryl Ruggles, as Cyril said. Today, I'm going to talk about Lambda Durable Functions. This is a feature that was announced at reInvent in December. And if you've been using step functions for orchestration or building your own custom state management setup, you're probably wondering whether this new feature changes anything. And the short answer is that it depends, of course, on what your workflow does. And that's what we're going to try to figure out today with some of the information that I'm providing. So a quick background on me. I'm a principal cloud solutions architect at Ciena in the network and telecom equipment space. I'm also an AWS Community Builder. I've been in this space for over 25 years, working on everything from C, C++ embedded systems, many years working with Java, React, now deep into serverless observability and AI spaces. Currently focused on organizing agentic AI development in our company across many different model providers and trying to right size our cloud spend through FinOps. My links and QR codes are up there on the page, and there's some demo code that I'm going to show later, and there'll be a link to that repo as well. So I was lucky enough to be at reInvent in December when Durable Functions was announced, along with a whole bunch of other things. And I thought that Durable Functions was probably the most interesting announcement to me. So I spent a little bit more time digging into it, and going to talk a little bit more about that here today. So uh, before durable functions, if you needed, in AWS at least, if you needed a Lambda to do things in sequence where multiple steps would take longer than 15 minutes, or if you needed to pause or wait for a human, you had a few options. Um, Building your own state machine, using your own custom logic, using something like DynamoDB, SQS, and gluing everything together, or use step functions, which works quite well, but one of the downsides is having to deal with Amazon States language. So anybody that's dealt with states step functions probably has some interesting experience with that. So with step functions, you also have to maintain a separate state machine definition, and I argue that it's not very easy to test step functions. So um, there are a few challenges with what was already there. So now that AWS has announced durable functions, they give you another option. You can use normal Python and Node.js code in your Lambda functions, and then let the Lambda SDKs and Lambda service handle the checkpointing for you. So, what are Lambda durable functions? I kind of think of them with four main topics or domains. So, checkpoints. So every time you complete a step, the result of the step is persisted by the Lambda service. Replays. So if a function gets interrupted, it reruns your handler from the top, but skips any steps with a cached result. Suspending, wait operations, pause execution entirely, and during this time you have zero compute charges, which is a good thing. Resuming, a new invocation picks up where the last one left off, and all the context is restored. So right now, the support is only there for Python 3.13, 3.14, Node.js 24, 20, sorry, 22 and 24. The SDKs are open source. Hopefully, AWS will add support for more combinations in the future. But this is the core, I think, of the offering right now. So the checkpoint and replay model is centered to the way durable functions work in Lambda. So on the page here, I'm trying to visualize a little bit about what happens at runtime. So this is some example from my demo application that I'll show later. It's basically a credit approval process. So where users apply for credit, and then their credit score is checked and validated, and then determined whether or not they're given the credit and what interest rate they get, for example. So in this example, on invocation one, your Lambda handler runs. Step one is executed where it validates all the application information, and the result is checkpointed. And then step two runs where credit reports are checked, and And once that's completed, checkpoints as well. And then it hits a wait. So in the example here, the wait is 3,600 seconds, 1 hour. So there could be many things that get done in that time. Inventory has to be checked, or in this case, for credit checks, maybe some kind of external system where a real human has to check something. There could be all kinds of situations depending on the use case. So the Lambda invocation suspends at this point, and you're not paying anything anymore. So a period of time later, another invocation starts. Whatever the system was waiting for has been resolved, or another version of checking it, some status is being done. So in the second invocation, the handler runs, but steps 1 and 2 have cached results. So they just get the previous run results directly returned to them, and no new execution happens for steps 1 and 2. And then step 3 runs for real. So the mental model here is that your code runs many times, but each step only actually executes once. So once you kind of internalize that, I think everything else starts to make a little bit more sense. It is a bit of a confusing topic, but um, that's the high level, I believe, of how I try to think about it. So there are different kinds of waits. You can wait based on a fixed time, like just wait for 10 minutes and then try again, or they can be triggered by external callbacks like a human approval or some kind of polling system where you're polling an external API. So when all of these waits are happening, the good thing is that you're not being charged for Lambda execution because it's not actually running. So this slide here just talks about some of the core SDK calls. I'm not going to really go over these, but we're going to go through some examples of these in the code down further. So here's an example of creating a durable function, and my example's in Python. Like I said, it's supported in TypeScript and JavaScript as well. So uh, in this case, it's mostly just a standard Python Lambda function, but we have some annotations here that kind of drive the durable function approach. So the first one you see on the Lambda handler is this annotation durable execution. So that's the opt-in to basically say that this Lambda is going to be a durable Lambda function. And then on each step of the durable execution, the annotation durable step is put. So the pull credit report and the validate application have the durable step annotation on them. So the checkpoint boundary of the whole flow is context step. So basically, in the risk equals context step and validate equals context step. So when context step runs, the checkpoint is made, and everything inside of the step is atomic, and the results get cached, as long as everything is successful, at least. And then there's an example here of a context wait. This is one of the types of waits. This is just a blind wait for 10 seconds. So basically sleep for 10 seconds. When that's running, of course, your Lambda stops execution and you're not being charged for anything. So everything in this code here is just normal Python other than the annotations and the SDK calls for the durable execution. So we're importing libraries, using variables, writing if-else blocks. There are only a few primitives that are part of the durable execution, like step, wait, parallel, callback, and a couple more. So the good thing with the durable SDK is that it's all locally testable with PyTest. The AWS team has provided a library that allows you to simulate the checkpoint and replay process all in memory, so you don't even need to be connected to your AWS account or any context to simulate that. So, and the deployment can be done with standard infrastructure as code. Like in my example here, I'm going to use the serverless application model SAM, but it works with the CDK, Terraform, whatever. So there's some examples below in my demo code that I'll get to. So these are the three kinds of wait operations. I kind of already talked about these. So wait for callback, wait for a certain time, and then wait for some specific condition. So we'll see some examples of this as we go. So one thing that trips people up with durable Lambda executions is they hear about the 1 year time, and it's a bit confusing what that really means. So uh, the 15-minute Lambda timeout per execution or per invocation still actually applies. You can only have a Lambda running continuously for 15 minutes. Durable functions don't change that. But what changes is the total execution time of the whole durable execution workflow. So that can be up to 1 year, but it's spread across many different invocations. So every time you wait in one of your invocations, that resets the clock again because your Lambda function basically stops executing at that point. So for real workflows, you probably always want to use asynchronous Lambda calls because synchronous invocations are still going to only ever last up to 15 minutes at the most. So most of what you're going to do with durable functions will involve asynchronous Lambda invocations. So this slide just talking about different approaches for testing. We're gonna talk about some of this later, so I'm gonna skip over this for now. This is an example of a serverless application model SAM template for deploying a durable function. I have an example in my project down below that we're going to go over, so I'm going to skip this for now. I guess one of the main things that people wonder about is pricing. We've all heard about cases where step functions on AWS can get very expensive. So here's kind of a comparison. The pricing model is a little bit different, but it is quite similar. Durable functions are charged based on operations, and operations are durable calls from for durable SDK calls that create checkpoints. So it's similar to the way it works with step functions, where each transition from one state to another has a charge. So it's $8 per million operations in durable functions versus $25 per million state transitions in step functions. So when you hear those numbers, 8 and 25, you might think that durable functions are always going to be cheaper, but you're also charged for all the Lambda compute while your durable functions are running. So it's not an apples to apples comparison. So, and also you have to pay for checkpoint data ingestion from the durable executions and also the retention of the checkpoint data. So there's multiple charges to figure out the total cost for durable functions with respect to everything. But in the step functions, if you don't actually call things like Lambda functions as part of your step function runtime, you're not actually paying for the compute of step functions. You're just paying for transitions. But if you do actually have Lambda functions being called as part of your step functions, then you're going to have to pay for the compute for those Lambda functions as well. So it's not a direct comparison. It all depends on the particular use case. So I think a good rule of thumb is that if your workflows are very compute heavy with lots of transitions, durable functions are going to be cheaper because you're not paying per transition or per state transition. If you're mostly just waiting for things though, without a huge number of transitions and because you're not really paying for the waiting and the compute within step functions, it's probably going to be cheaper with step functions. So it all depends on the situation. So here's a comparison of some of the key parts of durable functions and step functions. And I'm not going to read all of these, but there's 3 or 4 of them that kind of step out or jump out at me as the most important. So the paradigm of durable functions is that they're code first and imperative. Developers are probably going to be more traditional developers are going to be probably more interested in the step functions approach in the durable functions approach. Step functions are declarative state machines, so there's quite a difference in the paradigm between the two. Local testing, durable functions are much easier to test, I think. They're unit testable. You can just use regular tools like PyTest, can do it very fast, whereas step functions are quite difficult to test, in my opinion. I know AWS has provided some extra APIs for this to work, but it's still rather confusing, in my opinion, trying to understand how to test step functions locally, especially. AWS integrations. Everybody knows that's worked with step functions, at least knows that there are many integrations. I think it's like 200 or 220 integrations between AWS services, pretty much all AWS services. So if you're just using the integration calls that are offered in step functions, it's really nice and convenient to use step functions for that. So if you don't need Lambda calls with custom logic or anything like that, step functions is a real winner for integrating many services. Languages. So step functions require understanding Amazon States language. So I put it in red here in this chart because of all of the dislike I've had and all of the time I've wasted in my life debugging step functions. So, and in ASL. I started using the GUI builder rather than the ASL because I got so frustrated trying to get the formatting correctly in there. So the GUI builder works pretty good for step functions, but I'm not really the kind of person that likes using GUI builders for things. So it's a real plus for me that durable functions require me to not, or don't require me to learn or use Amazon States language, which I really don't like. So this slide, I'm just talking about some of the signals for when using durable functions might make the most sense. So if your workflow is mostly Lambda-centric business logic, if you're a code first team that wants to use standard testing procedures and IDE debugging and stuff, durable functions are probably where you want to start out with. If you have many long-running instances where you're suspending and resuming, waiting for human approvals, or calling external APIs, I think durable functions are probably a good starting point. When you require using third-party libraries, one thing that happens with step functions, is if you have many different parts of your overall workflow that require Lambda calls and business logic, you have to potentially set up and install many third-party libraries and all of those different Lambda functions that are part of your step functions overall workflow. But if you have a durable function set up, you can import all of those libraries in one place and have one Lambda function or a small number of Lambda functions that imports it all, and it makes it a whole lot easier from a setup perspective to not have to import all of those things all over the place. So if your workflow involves high frequency loops where you're iterating hundreds or thousands or even millions of times over and over, using durable functions is going to be much more advantageous from a cost perspective because you're not paying per transition like you are in step functions. So some signals about when to choose step functions. So if you have lots of cross-service orchestration calls across AWS services without really having to require any custom business logic, of course, step functions is probably a good starting point. If you have requirements for observability of what's going on in your overall step function setup and across all the iterations of the actual state machine, step functions is a big winner here. I think anybody that's ever used step functions knows that the AWS console visualization for step functions is really well done. It's very easy to follow the flow of all the states, and it's very nice to be able to track all the iterations of the state machine, all the invocations of the state machine, and what happened and what was passed between all the states. So if you need to separate the orchestration layer and the code layer, using step functions probably makes more sense because, of course, your orchestration is all defined in your state machine for your step functions, and then all of your business logic would be maintained separately. So if you have some requirements to maintain, to separate these, then step functions probably make sense. And in some industries, there are compliance and audit requirements where the visualization and the audit trail that's provided for step functions is much better, much easier to follow. In cases where there's high compliance and audit requirements, I think step functions is probably a good starting point. And if your workflow is mostly just waiting for things that take a long time and not really a high volume of transitions back and forth, step functions probably makes a lot of sense because you're not paying anything for the compute while step functions are running. It's just you're paying for the transitions. And if you don't have very many transitions, it's probably much simpler just to use step functions. So and as always, with anything, there isn't always one answer. So you could use a hybrid approach. So it may make sense in many cases to use step functions and use durable functions. So you could use step functions for the macro level orchestration of your workflow, and then for the routing and the cross service calls and such, and audit mechanisms to be able to track the overall flow. But maybe some steps in your step function are actually durable functions running in Lambda, and the complex business logic for handling all that could be handled inside of those durable function calls. So use both if it makes sense. So uh, this one here, I'm talking a little bit about Temporal. I'm not sure if anybody on the call has used that before. It's a much bigger scale and cloud agnostic implementation of durable functions. It's used by many large corporations for very high frequency durable function type execution, like Stripe, Netflix, NVIDIA. I personally tried it out a couple of years ago. They have two versions, a cloud offering where unfortunately the minimum spend is something like $500 a month, which makes it not really very useful for somebody like me to try out. And they also have a self-hosted version where you can take their implementation and install it in your own environment and manage it. I'm not really very interested in managing my own setups like that, so I didn't really explore it too much. But it does have some advantages in that it supports many different programming languages, and it's very well tested over time from some big corporations. So it's probably a solution for maybe not people that are watching this presentation, but maybe bigger companies that have requirements where they don't want to run in AWS and want to be very agnostic to the environment. Temporal makes sense, but at least for users that are tied into the AWS ecosystem, I think durable functions being added provide a lot more choice than what we had before. So Temporal might be worth looking into, but I'm probably not going to use it too much just because of the scale and the cost of the way it works. And I'm kind of using the AWS environment for most of what I'm providing. So some things to watch out for. I've read many different articles about gotchas and stuff like that related to durable functions. So I think one of the key things that trips people up is the whole replay mechanism. So your code runs multiple times, and you can't be branching on random numbers or timestamps. These kind of things will break the replay mechanism. So everything that's non-deterministic should go inside of a step. The 15-minute invocation is still rather confusing to some people. So each replay has a standard time mode of 15 minutes. You can't get around that just by using durable functions. So you need to make sure when you're designing your setup that you take that into account. Version pinning of your Lambda functions is important, and in many other uses of Lambda, this maybe isn't. But if your code changes while execution is suspended, like you're waiting for approval or something like that, the replay has to run the same version of the Lambda code as you were running previously. So it's important to use published versions or aliases of your Lambda functions in order for the whole mechanism with durable functions to work properly. Observability is still maturing. So in my opinion, the logging across replays with durable functions is rather confusing. You'll see duplicate log lines from the original execution and the replays. It's not really easy to jump through like a sequence of here's the things that actually happened in the flow. I find that there's a lot to be desired for the observability right now with durable functions. I'm sure they'll improve that over time, but uh, the what's provided with step functions, I think, is a lot better in this space. So. And of course, it's a new service. It's only been out for a couple of months, so durable functions has probably more bugs than other services. The SDK is changing. I think pinning the SDK version in your Lambda code is probably a good idea, but you don't want to change it underneath you, or don't want to depend on the default version that's installed. So some best practices for production use of durable functions, and I haven't actually used it in production yet, but I think if you were going to use it, these are some things to look out for. On the code side, I think you should wrap all the key parts of your workflows in steps. Never mutate closures and design everything for idempotency, because the whole checkpoint and replay model is a little bit different than I think what people are used to. So need to consider that carefully when designing production application. On the operations side, I think some of the key things, as I already mentioned, like use Lambda versions and pinning versions, bundle the SDK to ensure that you're going to have the same calls that you expect, set your execution timeouts appropriately, use Event Bridge for monitoring. I love Event Bridge, so use it whenever possible. Uh, Current availability. What was really strange when durable functions came out is I think they must have rushed it to some degree, because it was only available in one region, I believe, for the first couple of weeks, which made it quite a challenge to actually use. But they've come out with support in more regions now. I don't think it's not in all regions, but I think it's 15 regions. Support is there for Python and Node. Hopefully they'll add support for more languages as well. And of course, it's supported in all the infrastructure as code environments, SAMs, CDK, CloudFormation. One of the key limitations that maybe people aren't aware of is you can't take an existing Lambda function and make it into a durable function. You have to do that at creation time. So if you have existing Lambda out there already, you're going to have to redeploy them with the durable config setup to take advantage of this functionality. So here's a just like a key decision slide on when to choose what things to look out for. So if your workflow is mostly Lambda business logic, I think you want to start out with durable functions and see if that makes sense for you. If you have a lot of non-engineers that need visibility, they're not going to really be very interested in looking through your Lambda code. So in those cases where that is really important, I think consider step functions first, because the observability is much better. If you're orchestrating multiple AWS services, as I said earlier, there's so many integrations in step functions between all the different services. So step functions would probably be where you'd want to look at first. If local testing and IDE debugging is important, I think what's provided with durable functions is really, really well done. And it's going to be a lot easier for developers who are familiar with the normal development process to debug and test durable functions compared to step functions. If you have many high frequency loops, of course, because of the way the costing works with step functions, I think start out with durable functions in those cases and see if you can make it work. And if you just want very simple, you want one file, one artifact, put it all in one Python script or one JavaScript file, durable functions is probably where you want to start out. So And if you can't really decide between the two, you can always use both. Like I said earlier, use step functions as the overall orchestrator, and then have some key parts of the workflow use durable functions and optimize things like that. So I put together a code repo. We'll share the link after as well, but there's a QR code there as well. Um, the idea is that it's a credit validation system. So somebody's going and buying something, and they need to see if they can get credit to be able to buy it, to get it now, basically, and pay later. So there's a flow that I designed to kind of test out durable functions. So I'm going to switch over to the code for that. So this is my code repo. And what I'm going to do is I'm going to jump to Visual Studio Code. You guys can see the Visual Studio Code right through?
Yeah, sure. Thanks.
Yeah. Okay. So what I'm going to start with here is the template. So this is the serverless application model template. If you're not familiar with the serverless application model, SAM, it's kind of a wrapper on top of CloudFormation. So, but it's easier to use than direct CloudFormation. So what I have in here, a few different things. Some of it is more just to make it obvious how durable functions work, and you probably wouldn't really use in a production application. So I set up a DynamoDB table that kind of tracks all of the progress of all of the steps. This is the part that probably wouldn't be really used in a production application, but it helps me. I have a front end for this demo. The front end basically tracks all of those state transitions and shows them to the user. So the DynamoDB table is for that. And then the key part with the Lambda function and what makes it a durable Lambda function is this section here in the configuration for the Lambda. So durable config, where you set the total execution or total possible execution time for your function or your durable function. And you see here it's 1 hour, which is of course much longer than the standard Lambda timeout. And then retention period in days is how long the data from the state transitions that is saved is kept. So I think the default is 7 days, and I think you can set it from 1 to 14 or something like that. And then one other key thing to make this work properly is auto-publishing aliases. So you need to make sure that you're using a specific version, a qualified ARN, for your Lambda execution across all the different replays. Needs to be using the same version throughout. And then I have a separate fraud check function. The idea is that in a lot of workflows, you're going to want to reach out to external APIs or call external things. So what I've done here is created a fraud check, which in this case is actually just another Lambda function that runs in my application or runs in my account. And it's just actually sleeping for 5 minutes or 5 seconds, sorry. But this is where you could reach out to like a Stripe API or some other API to do something or check something. And the execution of your durable function will pause while that's happening. And one of the things that you need to do when you're setting up those external calls is permission to be able to resume the durable function workflow. So this fraud check function has the permission send durable execution callback success. So this is what allows it to resume the durable functions workflow once it's done whatever check it needs to do on some external API. So the main part of my example code is this a lone demo file. So it has a traditional Lambda function in here. So it has the durable execution annotation on it. And what you see in here is that all of the different steps of the overall workflow are literally context.step in the durable execution. So for example, the first step one is validating the application. You'll see some of this when I show the demo in a minute, but validating the information that the user provided for the loan approval. And then it's taking advantage of context.parallel. So in the durable functions SDK, there's a mechanism to be able to run many things in parallel, and they all get checkpointed separately by the SDK. So you don't have to actually handle errors in all of them individually. So you can do parallel operations in step functions, but you have to track everything, the error handling and such for each of those separately. One nice thing about the way that the durable function SDK has been set up is that you can do this all in parallel, and it takes care of it for you. So I have an example here where it's actually simulating reaching out to different credit agencies, and then when all of the credit agency results come back, it consolidates the information and creates a report. Okay, and then two things that I added to try to make it more like a real workflow is a human in the loop step. So in my credit approval application, I said that even if a person has really good credit and the credit agency reports are good, if the loan is over $100,000, then a human has to actually approve it. So there's a step in my workflow where manager approval is required if the loan is over $100,000. And the entire durable execution flow stops during that phase. So we'll see it in my demo here in a minute, but basically a pop-up comes up on the screen to the user and tells them, hey, this is a really large loan. Somebody from a manager level has to approve it. And until they approve it, the workflow stops. So we'll see that. And then I mentioned already about the call out to a fraud check. This is kind of a simulation of calling an external API. So after, if it was a large loan over $100,000, the manager would have to approve it. So either they approved that successfully or it was under $100,000, we would skip the manager approval and move to the fraud check, which is basically a call out to some external API. So in here, there's a step that makes a call, contacts wait for callback, and this is similar to if you've used step functions before. You can have tokens that you can call out to in a step function step, and then the external application needs to take the identifier that you passed and call back to step functions API to say resume the flow. So it's pretty similar concept here, where you pass an ID to an external service, and then when it's completed, it calls back, and the step function the durable function flow continues. So I'm just going to jump to the fraud check. So my fraud check is just a really basic simulation. All it's doing is it's sleeping for 5 seconds, which kind of simulates you calling some kind of external API to look up something. So, and it's just a separate Lambda function in my profile. So I'm going to jump over to, like, I've deployed the demo project that's going to be available on GitHub for anybody to try. I've deployed it into my AWS account, and also it has a local front end component to show the functionality. So I'm just going to click on the local React front end here for my application. So what you see here is kind of simulating an application where users would, via some kind of intermediary, probably somebody from the company that handles the loans, would input all the information for the user that's asking for credit, and then start the durable function workflow, which goes and does all of the checks and balances on whether or not the user is going to get approved. And what I've done is I've created 3 canned profiles just to make things simpler. So there's an Alice profile that whenever she applies for credit, it's going to always be accepted, subject to the manager approval if it's a really large loan. And then Bob's always going to get denied. And then Charlie, if he submits a credit check, depending on the amount, he'll get approved or denied. But what I'm going to do is I'm going to pick Alice. So Alice is asking for a loan of $150,000 to buy something, and here's her information. And when I hit submit application, it's going to make a call to the backend that's running in AWS in my account to actually trigger the workflow. So I'm just going to turn on the logging here, and you'll see the state transitions through the durable function workflow here. So the application was received, the application is being validated, a credit check was done at the credit agency. It did a parallel execution of the 3 different credit agency checks and came back with scores, her credit score basically for each of these, and then it calculated a risk score. And then it got to the step where it said, okay, if the loan is over 100,000, we need a manager to approve it. So the way I implemented it in my demo application here is that it just comes up on this screen. In a real application, will probably be some other user's screen that's actually a manager, and they would get a pop-up saying, hey, somebody is trying to create a loan application that's over the limit, and somebody has to manually approve it. So right now, the Lambda function, my durable Lambda function, is suspended. Nothing is happening. I'm not being charged for anything. It's just waiting. So if I deny this, what will happen is that the durable function workflow will stop. The user doesn't actually get their credit rating, or sorry, their credit request accepted. So in the log, what you can see is the manager, we were waiting at the manager approval at 11:38:06, and everything in the durable function execution stopped. And then after I chose no on the manager approval page, and you see it's like 44 seconds later. So in those 44 seconds, nothing was running. In the 44 seconds, sorry, when I denied the approval, what happens is the Lambda function started up again, but all of the steps up until the manager approval were already completed earlier. So it replays them, or basically uses the cached results for each of those. So here, validating loan execution, it shows replay because that was already done. So it doesn't actually run that code again. And then validate application validated successfully as a replay, pulling credit reports as a replay. So it doesn't actually do any of these again. It just uses the results from the previous run. But then it got to the step that wasn't previously run, application denied by manager. So that's the end of the durable function workflow for the case where the credit was denied. And I'll show this in the Lambda side, the tracking of this in the Lambda side in a minute. What I'm going to do now is I'm just going to do it again, but this time I'll actually approve the large loan. So it's going through the steps of the durable function, validating the credit check is running, risk assessment. And because it's over 100,000, I'm going to get the manager approval pop up again. So again, the Lambda durable function execution is suspended right now. So I'm going to hit approve, and that will allow the durable function execution to continue and progress further through the workflow. So because I approved it in this case, you'll see that it resumed just wait, let me wait till it finishes here because it's scrolling on me. So we got to the manager approval stage initially, and then at this time it was only like 10 seconds before I actually approved it. But after I approved it, 10 seconds later, it went in and the durable function ran again, but all of the initial steps were already previously run, so they just replayed. And then it got to the manager approved the application step, which was newly executed. And then it reached out to the fraud check service, which is what I have for simulating an external API call. So again, after it reached out to the fraud service, it paused basically because that was an external call. So in that time, you're not paying for your durable Lambda execution. You are paying for the fraud check Lambda call, but it depends on what you're actually doing in some of those wait states, whether you would actually pay anything or not. But then 7 seconds after the fraud check was requested and the Lambda paused, it resumed again because it got the call back from the fraud check service. And it's replaying all of the steps because they were already completed, including the manager approval, because the previous iteration where the manager approval was done. But the first new thing is the fraud check passed. So it resumed, went through the fraud check, and completed all the way to the end of the durable workflow. So if you see in the flow here, everything was accepted and the loan was approved. And here's the information about that process. So this is just a demo application to kind of show how the flow works across the different steps of the durable function. So what I'm going to do now is I'm just going to jump over to this in my AWS console to kind of show you how the backend works and what kind of observability you have. So this is the AWS account where the application I was just running is the backend resides. So I have 3 different Lambda functions here. So we have the fraud check function, which is the main durable execution. I'll show you that in a minute. Or sorry, no, the loan workflow function is the main one. Fraud check function is the one that is simulating the external API call. In my case, it's just like sleeping for 5 seconds, but it's an external function to simulate that kind of behavior in a workflow. And then loan API function is just an API gateway that's used by my demo front end there to get the status messages and such, and to send the signal back and forth with respect to manager approval. So if I go to the loan workflow function, this is the main durable function part of the project. So if you see here in the Lambda console, the thing that's different is it says type durable. So this is set up as a durable function. It has the durable config object on it when it was created. And the way the observability works in here is there's a new tab called durable executions, which is where you can track all the invocations of your durable function. So you see in here, there's many executions because I was testing this earlier today and last night. And if you look at the most recent ones here, there are, so the third one in the list is from 1014. So that's before we had our meetup. But then the 2 that I did while we were online here from 1137 to 1140. So 1137 will be the one where the manager approval came up and I denied it. And then the one at the top of the list will be the one that we just completed where I approved the large loan and it completed to the end successfully. So I'm going to click on the denied one here, and you get a visualization which is useful, but I think there's a lot of improvement that can be done from AWS to make this really something that's not confusing to the user. So even this very simple case where we opened up a loan application and in the middle of the process it got denied, we have 12 durable operations because every time a replay happens, it shows an entry in here for the replayed steps. So what I'm going to do, I'm just going to expand this just to kind of show what is what. So we have in my durable functions workflow, we have the first step was the validate application step, and then we had the parallel execution step where it actually reaches out to multiple credit agencies. You see all of them are running in parallel. I think that the best part about this observability is this timeline view. So you kind of see the green bar shows where in time of the overall execution each of these steps was running. So the validate application part was at the beginning, and then you can see that the parallel check for the credit agencies is after that, and all three of these are running at the same time in parallel. And then once the scores are received from the credit agencies, there's some code a step that does a calculate of the risk score, and that's done after all of those complete. And then the next step in the workflow is the manager approval. And you see here that the manager approval ran for a large period of time because I was talking. So basically it ran for 44 seconds. So these 44 seconds of the manager approval, the Lambda durable function wasn't actually running. You weren't paying any compute. We were waiting for the user. And this is the part that could be very long. Like this could be a year, depending on your use case, where you're actually waiting for something, whether it be some kind of external API to run or some kind of human in the loop approach. So this is the one where I denied the application. So it ends not long after that. So we're waiting for the manager approval, and then the manager approval was submitted. And because the outcome of that approval was deny, the workflow stops. And in this observability page, you have an event history, which tracks all of the continuous replays and invocations. And honestly, I find it quite difficult for our very simple application here. There's 28 entries. So can imagine that a very complicated workflow, there's going to be hundreds or thousands of entries in here. And it's not very obvious to me jumping around in here how it works. I find that this view here, where you can track the waterfall or the timeline view, I find is the most useful. So I'm just going to go back to the other one that we ran, which was the successful one where I approved the application. So again, in here, there's still quite a few steps. There's still 17 durable operations, but you see the validate step, you see the 3 credit check steps, the calculate risk score, and then again, we're waiting for manager approval. In this case, I didn't wait as long, so it's 10 seconds it was waiting, and the execution was paused. But then in this case, I actually approved it. So when I approved it, it went on to the next step. It did the fraud check or the reach out to the external API example that I had. And you can see here the green bar represents the time that the Lambda durable function was not running again. We're waiting for the callback from the fraud check API call for this period of time. And you see that the overall workflow only continues once that callback is received. So this green bar for generating the load offer and dispersing funds is after the fraud check. So, like I say, the visualization in here for the workflows is usable, but when things go wrong, I find it quite challenging digging through all of these steps and trying to dig into the details. Like it shows the output of all the steps. It's not very user friendly, in my opinion. So, I think there's a lot of work there to be done. So, let me jump back to my slides. Yeah, I think that's all I wanted to show. There's some links here for various reference information, and my demo code repository. We'll share it on the recap of the session.
Yeah, thanks so much. I really found this presentation very, very rich. I learned a lot.
No problem.
Thanks everyone for joining. Thank you. Thank you.
Yeah, thanks again. This was really helpful.
Yeah.
Thank you, everybody. Have a good day.
Bye
Bye.
again.
Bye.